All right, so we are getting into our infinite series unit. This one is going to be a little bit of a longer unit, just so that you know, up front. And it's tests of convergence. So basically, most of the questions are going to be, does the series converge or diverge? Today, we're just going to talk about what infinite series are, and we're going to cover geometric series. All right, so your infinite series, we're going to start with sigma. You are going to draw sigma a whole lot, so get used to it. All right. You do not need the calculator. So actually, before I say what it means, does anyone know what sigma means? Like summation. Okay, so we're adding up from n being 1, that's your first term. Sometimes it'll start at 0, it'll be your 0th term. Don't overthink that, just let it be, okay? From wherever you're starting to infinity of something, we just call it a sub n. So that would be a sub 1 plus a sub 2 plus a sub 3 plus ... forever. Which is the part that kind of geeks me out, is that you can add up numbers forever and get an answer, which is just cool. So an example would be something like 2 plus 4 plus 6 plus 8 plus forever. Now, if you don't want to go on forever, you can do what's called a partial sum. So instead of adding up an infinite number of terms, we can say, okay, we're only going to do the first 5 or something like that. So it is capital S sub n, and you would add up however many you wanted, or however many the problem told you to, usually is how that's going to be. So for the little series that I just made up, just 2, 4, 6, 8, blah, blah, blah. For example, say you wanted to just sum up the first 3 terms. You would just have 2 plus 4 plus 6, and you would get an actual answer there. And you can get an actual answer for the infinite ones too, and we're going to talk about that, but if you're not told where to stop, it has to converge. And actually, before we even get to that, would this one converge 2, 4, 6, 8, 10, 12? Well, no. What's going to happen to the numbers? Well, because the numbers keep on, they get bigger and bigger and bigger. You don't have that like leveling off effect. There has to be a leveling off effect in order for that to work, right? So if your partial sum converges to a finite number, then your infinite series is going to converge. If it diverges, like you get infinity, then it's not. All right, so let's list out our first few partial sums. Are we okay? All right, so if you have just the sum of the first term, that's literally just going to be the first term. You're just going to take 1 and plug it in for n. If you take 1 and plug it in for n, you are going to get 1/2, and like that's it. All right, so if we do the first 2 terms, that's going to be 1/2, which is what we just found, plus, and then what do you get if you plug in 2? 1/4, which would be 3/4. And we're going to do one more, and then we'll kind of try and figure out the pattern. So if you sum up the first 3 terms, it's going to be 1/2 plus 1/4 plus 1/8. Now let's talk our way through that, because the first 2 are kind of intuitive. You would need a common denominator, which would be 8. So this is 4/8 plus 2/8 plus 1/8. So 7/8. Yeah, and that's what we're about ready to write. Why is our second term instead of 3/4? Because remember we plug in. If you plug in 2 for n, 2 squared is 4, you get 1/4. Well, how come we use 1/2 for the first term, but not 3/4 for the second term? Like it was 1/2 plus 3/4. No, it's 1/2 plus 1/4 plus 1/8. What would the next one be? 1/16. Oh, I was thinking like the number we got was what we plugged in. No, you plug in 1, 2, 3, 4. It's your first term, second term, third term, fourth term. N is just 1, 2, 3, 4, 5, whatever. Okay, we're getting there. Hold on, I want to talk. If you think you know what it is, that's totally cool. I want to keep us all on the same page together. I think it's easier for this one to look at the denominators first. This one's 2, this one's 4, this one's 8. Any ideas what we could write as a formula to generate that pattern? Yeah, 2 to the n. This is 2 to the first, 2 to the second, 2 to the third. Now, what do you notice about the numerator compared to the denominator? It's 1 less, so it's going to be 2 to the n minus 1. Cool. Now, if you read the little thing that I put there, if your partial sum converges, then your infinite series converges. If it diverges, then it diverges. So we're going to do limit as n goes to infinity of this. I was about ready to say, the only thing that's really calculus in this unit 10 that we're going to do, is limits. We're not going to do derivatives. We're not going to do integral. Oh, actually, that's a lie. We are going to do some integrals. Sorry, I fibbed because one of the tests is called an integral test, so obviously there's going to be an integral in there. But there's not really like word problems. There's not rates of change. Like when you think about like related rates and stuff like that. I don't know. I kind of like it. We'll see if you guys like it. All right. When you go out to infinity, that's who's in charge here. The numerator is 2 to the n. The denominator is 2 to the n. They're the same. When it's a tie, you use the coefficients. Now, there's nothing written in front of either of these, so they're both just 1, and 1 over 1 is 1. Or you could think of it like they canceled out, however your brain wants to process that. Oh, can I finish the thought? Okay, so does the infinite series converge or diverge? Converges, because we got an answer. If it was infinity, then we would say diverges.
Do you need to write that the limit is that versus infinity? Is that not what the thing says?
Yes, that's what we're doing.
Like, do you need to write it separately that it's...
They're going to want to see a limit.
Okay.
Yeah. That's like the calculus of it. That's like the, oh no, more limits. Okay. Let's try it again. If you sum up just the first term, that would literally just be 1. Cool. And then if you do the first 2 terms, that's going to be 1 plus 1, which is 2. Every term in this series is 1. So if you sum up the first 3 terms, just to be thorough, I like to do at least the first 3, it would be 1 plus 1 plus 1, which is 3. Every single term is 1. All right, so what is the pattern? It's 1n. Yep, 1 times n, because for this one n is 1, and for this one n is 2, and for this one n is 3. So cool. All right, so limit as n goes to infinity of just n is infinity, and so divergence. Whenever I'm talking about this, I always think about that movie like Divergent. All right, this one's going to have a lot of fractions in it, just as a heads up. I gave you a heads up. All right, so let's give it a shot. If you plug in 1 for n, you're going to get 1 minus 1/2, which is 1/2. Okay, so the first one wasn't too bad. I like to do at least 3. If you can't find the pattern after 3, do a 4th one. Usually by then you can find the pattern. All right, so summing up the first 2 terms, it's going to be the 1/2 that we just found, and now we're going to plug in 2 for n. I'm going to do this as a margin problem because it is a lot of fractions. If we plug in 2 for n, we're going to get 1/2 minus 1/3. The common denominator would be 6. So this would be 3/6 minus 2/6, which is 1/6. And then we have to add those together. Yay. So what is that? 3/6 plus 1/6 is 4/6, which is 2/3. Good job. Well, we're going to do one more. So it's going to be 1/2 plus 1/6 plus whatever we get when we plug 3 in. Again, I'm going to do that as a margin problem off to the side. If you can do it in your head, go for it. Okay. So if we plug in 3, we're going to get 1/3 minus 1/4. And your common denominator would be 12. So this is 4/12 minus 3/12, which is 1/12. Then we have to add all those together. Common denominator is 12. I hear some of you working it out already. This would be what, 6/12? plus 2/12 plus 1/12, is that 9/12, which would be 3/4. Yep, we're adding them all up. Okay. Does anyone see the, well, I would do the numerator first in this case. The first one's 1, the second one's 2, the third one's 3. So your numerator is just n. And then the denominator is n plus 1. So I try to look at the numerator and denominator separately, and I go for whichever one feels easier. For this one, n is 1. N is 2, n is 3. So the numerator literally just is n. And I notice the denominator is 1 more than that, so n plus 1. And we're going to do limit as n goes to infinity of that. And again, going to infinity is who's in charge here? Yeah, the numerator is n and the denominator is n, so just 1. And so it converges. So this series for number 3 there is called a telescoping series. Do you know how like a telescope like opens and closes? Do you know what a telescope is? Like looking at the stars or whatever? Like, okay, anyway. It's going to look like this. A sub 1 minus a sub 2 plus a, like the second term. Oh, shoot, that should be a minus. Hold on a second. Talking and writing at the same time is... So what do you notice is going to happen? Well, we have minus the second term and then plus the second term. So do you see how those two would cancel out? And then these two would cancel out. And then the next two would cancel out. So the only one you keep, if you're going to do a partial sum, the only one you get to keep is the first one and then minus the last one. But it's the n plus 1th term. So you have the first one minus the last one, but it's a sub n plus 1. That's a partial sum. Your infinite series converges if and only if. If you don't want to write out if and only if, the official abbreviation is IFF. That's if. Did you remember if and only if from geometry? I teach geometry, so I know we do that. Like, that's back when you do the converse and inverse and contrapositive, and it's like, if it is snowing, then we are sad, and if it is not snowing, then we are not sad. Anyway, such and such, if and only if. Okay, converges if and only if your limit as n goes to infinity for this like leftover term is finite. So what does the word finite mean? Limited, like a number, right? Not infinity, not infinite. Okay, finite. So as long as that's finite, and your sum without a little number at the bottom, like if you have s sub 3, you summed up the first 3 terms. If you have s sub 20, you did the first 20 terms. If it's just s by itself, that's forever, that's infinite. I guess you could put an infinity there. Typically, we don't see that. It's that first term minus your limit to infinity of that like leftover one, whatever that finite amount is, as long as it's finite. That's a telescoping series, which you don't see super often, but I covered it. Hanging in there? Cool so far? So that's like dipping your toe into what infinite series are, wrapping your head around the fact that numbers go on forever and ever. We're going to cover our first specific one. I want you to think of this unit 10 as like tools in your toolbox. We're going to do a whole bunch of different tests, and each one is just a different tool in your toolbox. So today we're going to do geometric. For your sigma, they typically started at 0. Again, I don't want you to get super hung up on that. Okay, but that's the pattern for this one. It is a times r to the nth. A is your first term, and r is called your ratio. That's what you're multiplying by to generate the pattern. So it will look like this. A plus a times r plus a times r squared plus a times r to the third, et cetera, et cetera, et cetera. and then you do have to memorize this rule. Okay? It's going to be a good bit of memorizing. It converges if your absolute value of R is smaller than 1. It diverges if your absolute value of R is greater than or equal to 1. So that's your test. Do you remember P series? If you don't have any idea what it is, do you remember me talking about it? At one point I was like, hey, we're going to learn this later on. I'm going to just go ahead and say it now. P series is the opposite of this. P series converge if P is bigger than 1, diverge if P is less than or equal to 1. We're going to talk about it again, so don't worry about it, but just remember they're the reverse of each other, okay? It'd be great if they were the same. Now, if it converges, you can find the sum. It's A over 1 minus R. Geometric is one of the only ones we're going to actually find a sum for because we have a formula for it. Most of the rest of them, we just say it converges or it diverges. We don't actually find what the answer is. But if these converge, you actually can find it because we have a nice little formula for it. So let's give it a shot. I'm going to list out the first few terms. We're going to plug in 0. This one starts at 0. 2 to the 0. 1. So 3 over 1, which is just 3. Or you could write 3 over 1 if you really want to. Sometimes it helps to have the denominator there. So, up to you. Now we're going to plug in 1. So that would be 3 over 2. I do at least 3 terms. You can do more if you want to. I like to do at least 3. So we plugged in 0. We plugged in 1. If you plug in 2, 3/4. Plus ... So A is the first term, which is 3. R is what you are multiplying by to generate the pattern. So what are we multiplying by to get from here to here and from here to here? Yeah, 1 over 2. So absolute value of a half is just a half, and that is less than 1. So we're going to say converges because your absolute value of R is a half, which is less than 1. So if you need a justification, that's your justification. And because it does converge, we can get an answer. So we will actually get our sum. So it's going to be A over 1 minus R. So we said A is 3 over 1 minus a half. So 1 minus a half is just a half, right? So it's 3 over a half, which is 6. Why is it 6? Because that is the answer. You multiply by the reciprocal. When you divide by a fraction, you multiply by the reciprocal. So it's 3 times 2. You're going to do a lot of multiply by the reciprocal with this, okay? I want you to look at question 5. What is the only difference between question 4 and question 5? Yeah, it starts at 1 instead. So and I wrote right here, convergence is not altered by leaving off the first few terms. So if this one converges, this one does too. We don't have to write all of that over again. If we want to get our sum, this one we said was 6. We just have to subtract off that first term, or if you want to think of it as the 0th term, because instead of starting here, we want to cut that one off. So it would be 6 minus that 3 for the 0th term there, and so this would just be 3. So I wrote that on there. Convergence isn't altered by leaving off the first few terms. If one of them converges, the other one does too. Yeah, so see how this one starts at the first term? This one started at the 0th term. So we're just getting rid of that one. So I took what that sum was, and I just subtracted off that first term. Or the 0th term, if you want to call it that. All right, so let's try a few more. For this one, you can put a 1 in there if you want. It's 1 times 3/2 to the n. So A is 1 and R is 3/2. So what do you think? Converges or diverges? Why is it diverges? Because that's correct. Greater than 1. Diverges because the absolute value of R is 3/2, which is greater than or equal to 1. The equal to goes with the greater than or equal to. Because if R equals 1, your pattern would be like that one that was 1 plus 1 plus 1 plus 1. Do you get what I'm saying? Like, If it equals 1, it's not going to work. It has to be less than 1. All right, for this one, we're going to list out the first few terms. We're starting with 1. Oh, go ahead. There's nothing written there, so I said you could put a 1 in there if you want to. It's 1 times 3 halves to the n. If there's nothing there, it's a 1. Like it's like if you see a plain old x, it's 1x kind of thing. All right, so I would generate a few terms. I like to do at least 3. If we plug in 1, we're going to get negative 8 over negative 3. Oh, that would just be positive 8 over 3. And now we're going to plug in 2. So that will be negative 8 over 9. And then if we plug in 3, negative 3 cubed would be negative 27. Negatives cancel, so 8 27ths. Also, by way of foreshadowing, this is called an alternating series. That's a whole nother thing. Like, we're going to spend a day on alternating series. Do you know why it's called alternating? Positive, negative, positive, negative. Okay, so that's a whole thing, too. We're doing what? Oh, you are? I love that there's so much overlap. I hope that doing this helps you in there.
Oh.
What are you doing that's positive, negative? Oh. Okay, whatever. I'm going to move on. The first term is 8/3. And then r is what you're multiplying by to generate the pattern. I like to look at the numerator separately from the denominator. Sometimes that helps. The numerator we're multiplying by negative 1. The denominator we're multiplying by 3. So converges or diverges is the first question. If it diverges, we can't get a sum. So what do you? Converges. Good. So we're going to say converges because absolute value of r is 1/3. I did not draw that very well. Is 1/3, which is less than 1. And so we can actually get an answer. And again, that's the part that I love. You can add up numbers forever and get a singular answer. It's cool. It's cool. You can disagree, but I'm right. It is. It is cool. Get on board. All right, so we're going to have 8/3 over 1 minus r. That would be 1 minus negative, so plus 1/3. Got a couple more steps there. So it'll be 8/3 over 1 plus 1/3 is 4/3, and the 3's are going to cancel. So 8 divided by 4. So the whole answer is 2. It's cool. That's cool. If you add these numbers up forever and kept on going forever, like never stopped, it's 2. It's cool. It's cool. All right. Let's generate the first few terms. We're going to plug in 1. So our numerator would be negative 2. Our denominator would be e squared. This one's going to alternate as well. All right, if we plug in 2, we're going to get 4 over e to the 3rd. Let's do one more. If you plug in 3, you're going to get negative 8 over e to the 4th plus dot, dot, dot. So a is negative 2 over e squared. And again, that's a number. E is about 2.7. So remember, that's a value. R is, and again, look at the numerators and then look at the denominators. It would be negative 2 is what you're multiplying by in the numerator. And then E is what you're multiplying by in the denominator. So we need to figure out if this, the absolute value of this, is greater than or less than 1. Again, E is about 2.7. So if you have 2 over 2.7, is that bigger or smaller than 1? Smaller. If you have 2 over 2.7, if the denominator is bigger, you have a fraction that's smaller than 1. So we're going to say converges because absolute value of R is 2 over E, which is less than 1. And so we can actually get an answer. This one's going to be a little messy. Actually, it won't be too bad. I shouldn't say that. All right, so it's going to be a over 1 minus r. So negative 2 over e squared over 1 minus negative, so plus 2 over e. Here's what I would do. I would think of this 1 as e over e's, yes, so that I can get a common denominator. So it's going to be negative 2 over e squared over e plus 2 over e. And I got one more step. I know, you're like, is it over yet? You're going to multiply by the reciprocal. I'm running out of space, so I'm just going to multiply by the reciprocal over here. I'm just going to kind of do one of those because I ran out of room. And then one of the e's is going to cancel. So it'll be negative 2 over. Oh, I was even going to just, you're right. I was going to leave it like this, but whatever. I don't want to fool with that anymore. We found an answer. It's fine. I don't want to get into all the algebra of that. All right, we're going to write 0.7 repeating as a ratio of two integers. You can think of repeating decimals like these as infinite series because that's what they are. You get that bar over the top means it goes on forever, right? Okay, so if we write it, I'm going to write it out as a decimal and then we're going to write it out as a fraction because the fractions are a little bit easier to deal with. So this would be 0.7 plus 0.07 plus 0.007. Is that enough? Have you got it? Okay. Forever. And if we do that as fractions, this is 7/10 plus 7/100 plus 7/1000 forever. Do you see how it's a geometric series? So what's A? Let's start with that. A is 7 over 10 over 1 minus r. What are you multiplying by to generate the pattern? 1 over 10. And I am kind of out of room, so we're going to talk through this. 1 minus a tenth would be 9/10. So 7/10 over 9/10, the tens are going to cancel. And if you type 7 divided by 9 into your calculator, guess what you're going to get? 0.77777777777. That's cool. That's cool.